Hello, hello. Let me see if you can see everything. Yeah. Let's see. Okay, I'm visible. This is also visible. There we go. Okay. That's it. So, you are wondering what I'm. Yes. But first, we need wheel hubs. I am out of LP Power wheel hubs, so we need to make some. We need to make a few LP Power wheel hubs. So, there's two steps in the process. Okay, so you see, first there's this guy here. I went ahead. This is part of the turntable. Okay, so I went ahead and ground down these, and now we need some smooth sandpaper, and we need to make them smooth. Okay, and at the same time, the other problem is that's why we are here delayed. We need to make the diameter of this smaller, because right now, see, it doesn't fit, because this thing here is too big to fit into this square hole. So before we can glue them together, we need to make this smooth, roughen up this a little bit, and make this a little bit smaller. And of course, in order to not bore you, we're gonna do just 2 hubs today. Because that's basically all we need to start making the rear suspension of the Sierra. That's why we are doing this, because, you know, the rear suspension of the Sierra is kind of on the menu today. And first, I think I'm gonna sand down these. And then we're gonna move to the machining of the hubs. So let me get some sandpaper. Let's see. Okay. This one is gonna be perfect. Okay. So there we go. Well, one smooth part. Next one. I don't know why, but I killed all the flies in this room, all of them. Yet, without opening the window, without really accessing this room, flies keep appearing. I mean, why do I have spiders? They're not doing their job. And of course, there's another one. It's a complete mystery to me. A little bit small. Yep, looks right. I'm gonna make, I think, 2 more just so that I have a good sample size. Maybe, one doesn't fit well with one of the hubs. And since this is not precise, and I cannot do this on the lathe, because if I do this on the lathe and grab the part, then I basically damage the outer surface, and then it's not gonna rotate nicely as a hub, and then it's basically useless. So I need to do this in this manner. More. Yeah, that's good enough. Okay. That's good enough. Yeah, that fly is dead, but there's another one in the room. I don't know where they're coming from. And they cannot come in from the window because the window is closed, and they're not coming in from the rest of the apartment either, because there's no flies anywhere. So my guess is that they have eggs somewhere in the room and they're hatching somehow. I guess there's really no other explanation for it. They have no way of coming in anywhere else other than spawning. So now we check the perimeter. So everything here is fine, because all of these imperfections are going to affect the way the two surfaces mate. And of course, if there's an edge here, the rotation is not going to be smooth. But there's nuances which we'll explore if things don't go perfect. Okay. further so you can observe what's happening here. Makes it more interesting. There. Much more interesting like that. Which machine in the background? That's a Sherline mini lathe on which we are gonna work today. Hey Ben. No. The wheel hubs are just the beginning. We need to make the wheel hubs because otherwise we cannot do the suspension because I don't have any wheel hubs made. So we need to make them and then we move on to the suspension. So let's see. Okay, that works. It's a little bit of tweaking. Okay, needs to run relatively concentric, but you know it's never perfect because it's Lego. My mounting method is not perfect, so you know it is what it is. There's actually a thin line between where the wall of the part is too thin at the end and not thin enough. So we'll see. Sometimes it has happened in the past that the shaft has separated from the disc because I was going a little bit too extreme. We'll see. But ideally, we need to shave the disc as well a little bit. So that the two parts are gonna sit nicely with each other. And I'm by no means, if a machinist is watching this, I am by no means a skilled machinist. So if you are cringing, it's not my fault. So let's see what we've made. So it looks nice and smooth. Let's see. It's actually not good. So two things. We have an edge here that doesn't allow this part to sit properly in here. And this shaft here is actually not wide enough. So what's happening, you see, it should sit tight. It doesn't. So, I mean, we are gonna glue it anyway, because, you know, it's gonna be used regardless in something. But it's not perfect. And I know that Ivan, who is a machinist, self-taught, but nevertheless, he would probably rip my head off. So that's the edge taken care of. Now it should, yeah, it does sit smoothly. So this can be glued, but we are gonna do one better. So usually I leave a little more meat on it, and then if it's too tight, I take just a little bit more off of it, rather than take off too much. Yeah. Let's sit a little bit better. That's better. Okay, let's see. Should be tighter. You can see that we've left a little bit more meat on it this time. And it's tight. Yeah, it's slightly too tight. So we need to take off just a tiny little bit. that should do it. Okay. Okay. Let's see. Yep, that is perfect. Perfect. You see, it sits nice and tight, really smooth. This is tight, so the super glue is gonna grab both the surface here, the rounded part here, and of course it's gonna sit nice and tight against both surfaces here. Of course, I'm gonna roughen up this, which I forgot. Need to roughen up this surface. So it's gonna grab. Yeah, so you know, just so it has a key to grab on. Well, it's not a precise science, so as I said, I'm not a machinist. I do this by feel. So since I do this by feel, we get this. Hey, Mr. Amorti. But of course, now we have this set up already for the correct diameter. So we just go straight in. Well, this is not tight enough again. I don't think this lathe was cheap. This lathe is from Ivan. It's technically still his. I'm basically just using it. So I have no idea how much it cost, I must admit. Okay, so this one is perfect the first time. We just need to, it has, you know, these have a conical shape here, so we need to, you know, get rid of some material here. Or the lathe definitely not, isn't Lego. Where's my brush? I need it. Okay, see this gap, so it doesn't sit perfectly still, so we need to get rid of this edge here. Still not. See, it's not sitting. It's sitting apart, which doesn't. I mean, this is not good. This one is good because it's gonna be pressed together when we super glue it. But this one, yeah. I mean, here the problem is this surface here, because this surface is not straight. It's very uneven, so we need to get rid of more of the surface, which we did here. So let's turn down the surface. There we go. There we go. We're gonna repeat this with the other piece as well, just to make sure that both are good, and then we are golden. So you see, now we turned this surface, so it should be flat. It's okay, but still they don't fit. For this, what I usually do, because it's usually the edge around the shaft that I don't want to trim too much, because otherwise it loses structural integrity here when the shaft and the disc combine, because you know it's a thin wall here. Inside here is a thin wall, and it can snap. So there we go. If I do this, see how nice and flat they are. Very good. So we use this one, and with the other one we said this one, we're gonna turn this one as well to be as smooth as that. Then we can be confident that nothing is gonna detach. So when we do this, for the Chiron, you know, when it's happening, we need to do this really good. I'm even thinking of using screws to, you know, this mustn't detach, but if we do the surfaces as smooth as this, maybe I should develop a technique to be able to machine this surface to a perfect level finish as well. Then, yeah, I mean, as I said, the problem with this is how to hold it, because if you hold it here on the outer edge, we basically destroy the surface with the chucks, and we really don't want to do this. See how much the shape is conical. how uneven it is, and that's why then they don't sit perfectly against each other. Yeah, that's good enough. Yep. Now we just need to basically do the same as before. Make slight cutouts here to account for the edge on the contact, and it should fit perfectly. Okay, so now we glue. Now we glue. The machining part is done. Now we use super glue. There. So now we need to let them sit a little bit before we apply silicone lubricant. Before we put them inside of these two. Yeah, it would be epic on the Chiron if we had ball bearings, but you know, the point of all of this is to make it from Lego. We, if we go the ball bearing route, you know, at this point we can go basically fully customized. We could do this wouldn't be Lego. If we go this route, then we could do carbon fiber, everything, you know, wild engines and motors and stuff like that. That's not Lego anymore. So I think these are pretty good because uh, we can in the Chiron I would use instead of the silicone spray lubricant that I use, which I don't know. I use it in, you know, spray cans like this, different brands. I don't know. We would use well, basically grease, not lube like this, but we would use some kind of silicone grease that would be, it would at the same time it would remove even the slightest amount of slack that's left, and the grease would be, even when the temperature of the bearing, of the wheel hub increases, the grease would actually uh, grease it more. You know what I mean? It wouldn't disappear because I fear that the lube from the spray can, I don't know, at high speeds, who knows? Grease would probably be better, at least for the bearings. Okay. As we said, usually I put grease in these. And then a little bit something here on the outer perimeter. But not too much. You can always re-grease them later. Okay. This one runs freely. This one runs a little tighter, but still freely. And there's no, I cannot really feel any slack. I mean, yeah, you can hear it just slightly, but that's okay. I mean, compared to this, I mean, this is ridiculous. This is what you get with Lego, and this is LP Power. This is proper stuff. So yeah, these are both nice. What I do after every bearing assembly, it's not necessary, but I do it anyway. I do run them in a little bit, because this frees them up just, a tiny little bit. And then they run perfect. Oh yes. Now this one needs a little bit more. tiny bit more. I mean, what's happening here? I'm gonna explain to you what's happening actually. So the problem is this: when I send down these, if I happen to send them down a fraction too much, then this here is gonna rub against the outer edge of this too much, because the edge of this is slightly larger than the edge of this, and when you then spin the bearing like I do right now, you wear them in basically. So I mean, it's tiny amounts we're talking about, but it still happens. Of course, if Lego did this as a mold, this wouldn't happen. Oh yeah, yeah. They are both now free, and this is it. Now we are free to do the rear suspension. Now I need to reshuffle things here around a little bit. Into their usual positions. Go. So we just made two LP power wheel hubs. They are, as said before, they are far superior to this, to the Lego wheel hub. Lego wheel hub comes in a few variants, but they all share the very same flaw. They share slack. See, they have a lot of slack, and when you put a large wheel on it, it just multiplies. I mean, when you have a large wheel on this, even if you mount this as rigidly as possible to a chassis, so that it doesn't move, that this part doesn't move at all, the wheel that you put on this hub is gonna just wobble around. And I mean, for a toy, for a model that you put on a shelf, it doesn't matter. I get it, you know, I get it. I'm not that zealous, but we don't do models just for the shelf, you know. At least I don't. I like my stuff to be well, tight. So when you drive a car with remote control, like we will do with the Sierra, because the Sierra is going to be remote controlled, unlike the Charger. I mean, Charger still, whoever wants it can make it remote controlled, and you definitely should put those wheel hubs on the Charger. Charger right now has these on, as will be evident in the building instructions, but it's ready for these. You can put these in whenever you want. Okay, so here you don't have any slack, and when you have a precise suspension, you want exactly this, because you put all your effort into designing a suspension that is tight, doesn't have any slack, you know, all of the correct geometry, and then you mount this hub, which destroys everything. I mean, the wheel just goes wherever it pleases. I mean, that's not how we roll. So we use this. So yeah. This said, let's see how we can do the Sierra suspension. First, let's decide on the half shafts, the differential, and the width of it all. The planetary gearboxes are garbage as well. Let me find them where I have them. There we go. So they have just as much as everything else. Maybe tiny bit less, but there, when you mount the wheel, it flops around just as much, you know, and this doesn't. This just doesn't. And you know, the Lego wheel hubs are still better than axles. If you put the wheel just on an axle, it's I ever since Lego introduced wheel hubs, in all the big models I do not use axles to mount wheels anymore. Oh my god, Ben. Do you realize how this just sounded? Oh my god. Oh my god. So we are definitely gonna use these as half axles. Then we are definitely gonna use this as a differential casing. Definitely we are gonna using this differential. I'll leave this here. So we need to see what the width of it all needs to be. Right now I just want to get the width, and then we can work on the half axles or on the trailing arms and stuff like that. Okay. Of course, these of course have flaw, if we can say this. They require us to have this part wider than I would like, but that's how it is. And of course we absolutely connect these in this fashion, because the small these small CV joints are useless. They pop out immediately, and I don't trust them. These don't. So if we want to do a serious car that's gonna be reliable, we need to use these. That's just how it is. Okay, so we want the track to be about the same width as the rear, the front. Ideally, as wide as this. Yeah, I know that's why you wrote it. I know fully well why you wrote it. You bastard. Okay, I'm gonna mount this. temporarily, so that I can eyeball the width. There. Well, it's gonna be easier if I do it in reverse. Okay. There. So I want this to be you can see enough. Okay, there. Now you can see what I can see. Okay, so there. I want this to be held in place, so I can determine the length of the half shaft here. I said it. So looks to me like a 6-stud axle. No, 4-stud axle should be what's needed. No, it's a 5. What? 4.5. Really? What about 6? 6, 5. Oh, 5. Yeah, 5 is right. Is it? No. Let us try. Well, ideally, it would be, as Ben said, half a stud, of course. This was half a stud shorter. This would be ideal, as usual. My God. But yeah, ideally, we are gonna make it 4 studs here. Just have to keep my eye on this, because if it tilts, it actually skews the results. So yeah, it can be a 4-stud axle here. Exactly 4 studs. So this is perfect. Okay, and we can make a nice mounting point here, so it's it's supported a little bit more. So it's gonna be perfect. Very good. So this is our differential case. We know the difference, the distance here. Very good. So that's basically our rear drivetrain. Of course that would happen. Okay. Well, I'm not gonna mount these. Now I can take you to the usual location. Yeah, I mean, a drill, if you don't have anything else, a drill can do stuff, but it cannot replace a lathe. Not really. For grinding stuff, a little bit, it's okay, but a lathe is still a lathe. There's no replacement for it in a proper workshop. Okay. So obviously we are not gonna tolerate 4-stud axles here. We are gonna have these instead of the 4-stud axles, obviously. For looks and for stability there. Okay. Okay. Just gonna pop this in. The good thing about the differential here, and we are gonna also make it in a fashion, you can always flip it. Of course, depending on the engine that we use, some engines turn clockwise, some engines turn counterclockwise. You know, if the engine turns either way and it's the wrong way to run forward, you basically just flip the differential. So it's very easy to accomplish here. And now we need to take a look at pictures again. So let me fire up the file browser and let me share a few pictures with you. So this is one of them. Another one. And yet another one. And I'm gonna take a look at them myself as well. Because this is basically what we need to replicate. The geometry here, of course, is important. Note in the drawing I did not make the lines. It's just a picture I got from the internet. This is basically the geometry, and someone has made the homework for us and determined that the angle that the trailing arm is in relation to the this line is 6 degrees, which is nice. Of course, we are gonna need to do some photoshopping ourselves, because we need a straight line to which we need to match Lego geometry. So yeah, it's a nice drawing, yeah. So well, degrees don't really matter. What matters is how the geometry here is gonna pan out. So for this purpose, I'm gonna open this in Photoshop. Yeah, I don't really care how much it is, because you know, I'm just gonna match the angle, whatever it is. But for this, I need to actually make myself a ruler. So I'll make a ruler. I'll make it, I don't know, in some color that isn't red. Let's say green. Yeah, green is good. Green is good. Mm. And I'm gonna make another one. There. Uh, I always forget how this is done. Deselect, okay. Now I can move this, yeah, to here. Now I can rotate the layer, I think. I need to see if you can see anything. So um, okay, how is this done? Select all, and then I guess it's, yeah, okay. So this, oh, I even almost have it in the first try. Okay. Yeah, so this is basically, yeah, that's the angle that we need to observe, whatever it is. Okay. So yeah, okay. So now that we have this, basically why we need this? Why we need this? Simply because now we use the standard method. We use these and, well, just mimic the angle. There. That's the angle. There we go. Now we need to fix it so it doesn't move, and then we can replicate it. Basically, what we need the attachment points go from this, but the wheel itself needs to be still perpendicular to this. So the wheel is like that, and the axis of rotation of the trailing arm is this. This, of course, causes changes in geometry when the wheel is going up and down, which we are, of course, gonna explore. But first we need to recreate this angle. And let's see if it's as simple or similar as in the E30, because in the E30 I already did something like that. If it is, perfect. If it's not, we are gonna, you know, investigate and do something, as we usually do, and the results are, well, more or less okay. More or less. Okay, I moved it. That's not good. Okay, so now I can look at it again and see, you know, where this corresponds. Okay. This looks absolutely spot on. There. And the good part is that we have a nice, basically square triangle. It corresponds to Lego geometry pretty good. Pretty good. Yep, it's exactly. So that's nice. At least we have something going for us. Okay. Good. Now we need to make another section here to make us a square. A square here. And then we can investigate this relation. There. Okay. So this, of course, represents our wheel. When everything is flat. Okay? As soon as this is not flat, so as soon as our trailing arm is not flat, there will be some changes in camber and toe. But that's the point. That's the point of this kind of suspension. The change in camber and toe, and this is what we're gonna investigate. Okay, now let's see. Let's see what the options are. So in the E30, I used this little piece, but here obviously this isn't gonna be the case. It's gonna be, well, it's a lot flatter. The angle here should be a lot different. Maybe a number 3 here. Number 3 here. Or, I mean, alternatively, we can have, as far as I can see in the Sierra blueprints, there are, since the pivot that's happening here on the Sierra is much further out than in the E30. So in the E30, the pivots are, you know, inside the body of the car. In the Sierra, everything, this is spread out a little bit. The axis is the same, of course. There's no difference. The changes in geometry are the same, it's just where it attaches. So here it attaches a little bit more spread than in the E30. Not sure if this is good or bad. I guess it's good since there's room. Okay. So now there's a few ways how to do it. One of them, of course, is to make it like in the E30, where the pivot, the trailing arms pivot around, an axle. The other way would be, of course, to make it basically with bionicle joints, so that these two pivots here would be bionicle joints. This would free us, of course, from having to line up everything perfectly, but it would introduce more friction, of course. That's the downside, of course. So we are gonna explore the axle approach first, because that's my favorite. And then if this fails, we're gonna explore the bionicle joints. With the bionicle joints, if we want to do this well acceptable, we need to grind them down so that they move freer. This is exactly why, if possible, I would not do it. Okay, let me get a few pieces here. So let's say, no, this is a 4, this is a 3. Okay, let's see, 3. Let's take another one. And I would like some axles. Okay. 3. Is it only me, or is the 3 connector the perfect choice? Well, you're not gonna know until we extend this, so we can align everything better. Okay. Everything is so far away you cannot even align it. I'm gonna make myself some tools like this. Okay. Does this still look parallel to you? Because it doesn't look parallel to me. Not anymore. At least I think. But I could be wrong. So what I'm gonna do, I'm gonna fix this. This needs to be perfect. Yeah, it's not parallel. It's not parallel. See? So the number 3 connector is not our friend. It's not our friend. But of course, does matter. Okay. We need to achieve the achieve. My English is really atrocious. So, first we need a pivot in our training arm. Here I'm really not gonna be concerned too much with attachment points, with correct length of everything. I just want the geometry. Then we can shift everything around the way we want. So basically what I want, I'm gonna come on there. I'm gonna substitute this for the wheel hub. So ultimately what we're gonna do, and I'm looking at the blueprints right now. This is of course, yeah, gonna be different, but bear with me. So basically, I want this angle. This here. I want this angle. Yep. And for this, I'm gonna. What am I gonna do? I'm gonna use these. And again, everything is so black that you can hardly see anything on the screen. Okay, this and this. No, that's what interests me. So this is basically the first attachment point. Now we need to make the second attachment point somewhere else. Let's say here. That's not the correct spread for us, of course, because this and the inner pivot need to be far apart, and the inner pivot is basically gonna be just next to the differential, and the outer pivot is gonna be it needs to be, if this is the wheel, this guy here needs to be basically here, so basically outside of the wheel, so they need to be apart for quite a bit. That's not what interests me. What interests me at the moment is the geometry of how to make the connection between this and this rigid, so that they don't move. That's what I want to know. again, I'm looking at the blueprints, the file I linked to. Let me there. Let me link you the file that we made now again. There, that's the photoshopped file, and now we need to see where we are at, because I can see, of course, on the blueprint. Where is it? I can see on the blueprint that the trailing arm has a very peculiar shape. So it's not a straight line, but from here we can have, you know, not this extreme, but there can be a kind of bend that goes to the wheel hub, and that bend can be, you know, made with, let's say, another beam going like this or something. Of course, we don't want a lot of stuff going on here in the rear. Behind it, well, here behind behind the drive shaft, we are gonna have the anti-roll bar and the spring mount. So originally in the Sierra, the spring is basically mounted in the front. We could do this in the front, depending on how we may manage to do this. But if we have this in the front, then we have to take into account that the force of the spring is gonna act on the mount of the suspension bridge. Not necessarily bad. It all depends on how we manage to secure everything here in place, and then how we mount this this part here onto the rest of the car. Then we may have the spring in the front, which I would maybe even prefer, you know. But we'll see. We'll see how we're gonna mount this, and even I'm not sure which spring we're gonna use, because if we replace the shock absorber with a unit, so like in the E30, I replaced the shock absorber with the spring. Basically, the shock absorber was the spring, since it had to be there anyway. So yeah. And if it's here, then the spring can be softer because it has a longer lever. Yeah. Well, that's the philosophy behind it, at least. Okay, so this is not an easy geometry problem, because in the E30 I solved it actually pretty easy, if I remember correctly, because I think I used this. No, come on. I think I used this, and this went. Where did it go? Did it go to the inner one, and then the outer one was? Let me check on the E30. I forgot. Completely forgot how I did it. Where are the pictures? LP power E30. Where is it? There we go. There we go. Where is the rear suspension? I completely forgot how I did it. Luckily I have pictures. Oh, okay. There we go. So picture number 1, picture number 2. Not saying that we are gonna do it like this. I just want to remind myself how I did it. Ah, yes. Okay, yeah. That's how I did it. And this was actually pretty damn stiff. Okay. We may actually do it this way. Yeah. Because this is gonna be stiff. Need to see about the geometry here, but yeah. We are gonna use this system. Because this is really the only way we can do this reasonably stiff. I think. I could be completely wrong, of course. Wouldn't be the first time, of course. But, you know. So, basically, it's this guy goes to the inner part, and then we have basically another part going to whatever and wherever the outer joint is. And it's, yeah. And for this we need to know exactly the placement of these. Okay. And for this, of course, since the Sierra rear suspension is like beams, you know, like beams going in a V over the differential, and the rear suspension, actually, the mounting points for the rear suspension are on this at an angle, which in the real car is not a problem, of course, because you just weld the piece at whatever angle you want to it. But it's not as simple in Lego, because we need to adhere to all of this geometry. God damn it. So it's a lot more complicated than the E30 suspension, simply because of geometry. The more I look at it, the more my head hurts. Oh god. Yeah. So basically we do need to make all of this proper. Otherwise, well, all of the angles depend on it. All of the angles depend on it. Okay. So basically, okay, the way I see it, this guy is where it needs to be. Okay, in relation to this guy is where it needs to be, but this guy needs to be more to the outside, more on the outside. Yeah. So it basically needs to make needs to go around the wheel, if you like. If you take a look at the blueprint, basically. Where is it again? Come on. Here. Here it is. Yeah. If you look at this picture again, so basically we need the outer pivot needs to be where the just where the inner edge of the wheel is. Needs to be the outer pivot. The inner pivot here is fine, at least the way we have set it up here. So if the wheel hub is here, the inner pivot is fine. The outer pivot needs to be further outside. So we need to make the connection to the from here to the inner pivot, and yeah, a few more things, of course. One thing that I didn't take into account when comparing this and where this needs to be is, of course, when we place the wheel here and look at the picture I just posted, of course, and the axis of where this goes, I kind of think it needs to be a little bit, this axis needs to be a little bit closer to the wheel. It looks to be, when we move this here, it's going to be too far away from the wheel. That's how it looks to me. But I mean, let's examine some pictures of it under the car. Yeah, I think it needs to go. I think it needs to be slightly closer to the wheel. Because now I need to disassemble this, or at least turn it around so that I can have access to this part here. There, yeah. I'm gonna move this like this. So, I mean, I'm gonna place the inner part as close as to the inside as possible. And then so that's kind of our relationship here. This guy needs to be close to the differential here-ish, somewhere here. And then we have this here, and then the outer one is, well, outer one is, if I eyeball it, it's gonna be here. It's gonna be here somewhere. Let's say it's gonna be here. Okay. Yeah, this is about right. course, the area here needs to be completely different, because when you mount the wheel here, then this part is going to be in the way, so it needs to curve around, you know, to allow the wheel to be here. But the distance from this to this is about right. So we have the basic geometry is there. Now we just need to make one trailing arm out of this. That's, you know, that's not wibbly wobbly, because this is all that there is. There's no additional suspension links. It's just the trailing arm, and that's all it is. Trailing arm, and this is the axis of where it pivots up and down. So it needs to be strong. If this isn't strong, then, you know, then it's Jesus. How are we gonna do this? This is gonna be very tricky, because we basically need to leave room here, because there's gonna be the U joint, the CV joint. It's gonna take up space here. So if we start here, or anywhere here with our lift arm to connect it to here, we may have problems. The main problem is here is the best position for it, of course, but the main problem here is that then we shoot past this. We shoot way past this, because the E30 suspension, the angle is not as steep as here. So the camber changes are gonna be much more pronounced here in the Sierra. Yeah. My God. We cannot go like this. And we cannot go like this, because then we get here, not here. We can move this down the line, of course, but then there's no way we can mount anything here. You know, if we mount this here, that's not a problem. See, that's not a problem. There's room. This can spin freely, but as soon as we move it back, these two collide. And then ideally it would be here, but of course it cannot be here, for several reasons, of course. First of all, it's gonna collide with the wheel. Second, there's no room for the CV joint. And third, if we do this, then we have no room or no way of mounting the second pinhole, and this is gonna flap around. So what we're gonna do? We obviously will have to, if I look at the Sierra suspension, we're gonna have to simplify. Yeah, we're gonna have to simplify it anyway, but we're gonna use some right angles, I think. Some right angles. For example, this fella, and we would basically make this, and then we would go like this, I think, from here. But we would use this so that we have a pinhole free here. That's the general idea, of course. How exactly it's gonna pan out, I don't know. So something like this, maybe. No. Okay. This still doesn't reach it. So what if we, well, we have to extend it any further. Okay, this does reach it, but it's too long. What about this? This has a fair chance of being thereabouts. Yeah. It's good to work. It's good to work. Then we need, well, just a, where is the E30 picture? Something's, I mean, yeah, the E30 had, both were, or were they? Yeah, both, I think they both were pivots as well. Where is it? No, they weren't. Okay, only one was pivoted. Okay. Okay, I understand. So basically, at least one of the arms, if you want, needs to be completely stiff. The other one can be pivoted and just be an extension. Okay, so this isn't perfect either. Needs to be even one stud more to that. Yeah, but it needs to do anyway. Yeah, needs to anyway. There. Okay. Yeah. Now we're talking. And here, you now need to see how much we need to. Oh God, yeah. See. Now we need to think about. God, focus. You see, we need to think about mounting the arm to the front here, because in here we are stuck. So we need to go from here probably, or from here, depending on what we do, so that we go around the wheel to the front. Okay. So here or here. What are the odds? What are the odds? The odds are good, to be honest. You know what I mean. The odds are good. This, of course, is not how it's gonna look like, but I'm just looking at the geometry. I'm looking at this would be, of course, pivoted on this. This would pivot. This would be fixed on this. This is an alternative. Let's mount it this way. Okay. Does it even mount? Yes. Almost. So, where do we have leeway? We don't have any leeway here. So if we make this, come on. It's bothering me. Okay, I'm gonna mount this with an axle because I don't care about pivoting right now, up and down. I care about geometry. And this is the edge of the car basically. So this needs to be there, like that. Here we have a slight pickle. Let's see if we can half stud it. No, half a stud doesn't work like this. Could work like this, maybe. No. Jedi, if I will try to make a mechanical model plane, no. Planes do not interest me, and making the fuselage, it's not my thing. There's others that have more interest in this. I'm interested in cars and vehicles, but I'm definitely gonna do a truck in the future. Definitely. The more I look at, you know, either modern actresses or whatever, or I don't know, something on the road that looks impressive, the more I want to do trucks. Not necessarily. Not necessarily. Yeah, I mean, let's see if this is gonna happen. Let's see, so that we don't investigate this. Yeah, it's gonna hit the bent beam. Okay, it needs to be somewhere else. So let's say further there. And then maybe the geometry is gonna pan out better. so if the bent beam is here, and then this is further there, I'm kind of wiggling it so I know that, just to know that there's no tension anywhere, that I wouldn't be looking at the geometry that isn't legal, you know what I mean? Because one can easily do the following here. One can easily do this. See? And this works. This geometry actually works. And you see, even with the LP power wheel hubs, you see this wobbling. You know where it's happening. Can you see it? Can you see where the wheel is wobbling? It's wobbling on the pinhole, on the pins. So if you mount this to LP power wheel, to Lego wheel hubs, you have a compounded wobbling. You have wobbling in here and in the bearing. So it's, I mean, I have no words, you know. I don't even, I mean, this is easily fixed, of course. I can just put a screw in there and then this isn't gonna happen anymore. And it's, as you can see, even if it's wobbling, it's not gonna hit this. So we're fine. Of course, if you decide to put bigger wheels on it, it's not gonna work. It's made for these, but you know. And you have to keep in mind here that basically these are trailing arms, and the car is gonna be pushed by the wheel to the front. So this needs to be really strong, and it is. It actually is strong. Not fully, because this is just a dummy to experiment with the geometry, but it works. It works. So the pivot axle, of course, is here now, which of course doesn't pivot because, you know, obvious reasons. And I think we should let it pivot. I'm gonna put in these because I want to see what it's doing. There we go. We can omit this. Okay. Wait. Sorry. There. There. That's our geometry. Okay. So obviously, it's happening like this. If you imagine, this is, well, gonna be the side of the car. I'm gonna mount this to mimic it, so you can observe what's happening to the wheel, and the changes are quite dramatic. Okay, so that's how our relation is. Okay, now let's say our wheel is level with the ground. So the trailing arm is at right height, and the right height is level with the ground, which is quite normal. Okay, now if you lower the car, suddenly you will notice that we gain a lot of camber. And if you lift the car off the ground, see, the camber changes again. So from afar, it's more visible from afar. So these are the camber changes when pivoting up and down. See? Quite a lot is happening. So basically, we want the right height to be here, where the wheel is squared to the ground. But that's not the only change that happens. So if we look at it from above, you will notice it's not as dramatic, but the toe also changes. So when the wheel is off the ground, basically when the car is cornering and it's driving this way, no, it's driving, actually it's driving, yeah, that way. So we're driving that way, and the rear is unloaded. Okay, the rear is unloaded. So this happens. The wheel tilts inward a little bit. And when the wheel gets loaded, let me see if I see this correctly. Yeah, and the wheel gets loaded, the toe changes to the outside a little bit. So it's both the change of toe and the change of a camber. Basically, this was done in the 70s to mimic what later on a multi-link suspension did. So the multi-link suspension that basically, I think it was Mercedes in the W201 that first introduced the complicated multi-link suspension. Well, it's designed to basically make the car behave better in corners, so that the rear wheels prevent the rear from breaking out. That's the basic idea, and the E30 has the same thing basically. Just the angles are different. So the E30, the Ford Granada, the E21, the BMW 2002, Mercedes, I think it was from the W215, 115, 116, basically all of the Mercedes cars from the 70s had it. All Fords with independent rear suspension had it. BMWs had it all from the E12 to E21, E28, even E34 had this suspension. And even today, you can find cars that have this exact setup, simply because it does its job actually pretty good, pretty well. It's not perfect, but for the price, so it's basically just one suspension element. It's just a trailing arm, nothing else. Trailing arm and the beam connecting both trailing arms that bolts to the suspension. And the Multilink suspension is a lot more expensive because it has a lot more parts that can fail, and stuff like that. So this, for its money, it's very good value. And if you have a car with this suspension, it's fine. It's actually more than fine. It's pretty good. It's the closest you can get to a multi-link suspension. So yeah, that's our geometry. Now, from here, what we need to do is make this into something that's gonna work as a suspension, of course, because this doesn't. It takes way too much space in the vertical. At least here, it's of course not gonna be proper. I mean, it's stiff. Don't get me wrong. This is already as stiff as I would expect it to be. Maybe I would like a connection here. I'm not really comfortable with this, but maybe we can maybe utilize this. Maybe it would change a few parameters here and there, but I think it would, if we use this, would make this simpler, and we can still find a solution here. This would change a little bit, but I would prefer to use this actually. Yeah, I would like to use this if possible. And I'm gonna use it on this. So I'm gonna leave this as is. I'm gonna do a second set with this to see if the geometry, well, kind of works. Not sure I'm entirely comfortable with it. And yeah, I think I'm gonna use this. I'm gonna use this and cannot use this. We have to use this. Oh, wait. We have to use, of course, we have to use this. Not entirely confident in this. No, this is already introducing slack that I don't like. It's so tempting, so tempting. Let's build it anyway. Let's build it anyway, and we'll see where it takes us. Okay. Okay. Okay, so this is now gonna mount to this hole. Yeah, I think the wheel fits over this. Perfectly. Wheel has no problems. So now where would this fit? And of course, we are assuming that this is gonna be the right width of the car. We're assuming. Still, you know, we need to then fix this and see where the center line is, and then see if the wheel is correct. And you know, the compact has the same suspension. The compact has the rear suspension of the E30, basically. Parts are interchangeable. Yes. So let's remove this. Set it aside. No. Again, I'm gonna use these for now, just to make sure that we have the geometry. I need to extend this, of course, to this side to see that we have adherence here. And yeah. I thought so. Okay. Thought so. Now this is too far. This is too far. Yeah, of course it's too far. It's... But is it? No. Well, then this was too far as well. Yeah. This needs to be closer. closer. Jesus. Anyway, my concentration is already waving here. So I think we should make a break here. I think we are on a good path here with geometry. I think I'm more in favor of this setup, although it has the 90-degree bend here, simply because there's no way we can make this anything other than an axle, and if it's an axle it's gonna have slack, and I'm not comfortable with slack, and this is not gonna have slack. There's gonna be slack of a different kind, which here may not be possible. That is true. That is true. But I have to think of a way to do this without the slack that's inherent in here. So we'll see. We'll see. Both options are on the table. Like literally. They're literally on the table. And one of them is gonna prevail. Maybe even a third option. You know, maybe even a third option. Because we still can do something with this. You know, we still can do something with this. Maybe. No. There are options available. Well, maybe not, but you know. We'll see. I have to sleep over it, because yeah, definitely I have to sleep over it, because my subconscious will try to find a solution here. It was the same with the E30, and then suddenly, you know, it pops out, and you're like, yeah, how did I not think of this before? Yeah. Anyway, we may not see each other on Monday, but we could see each other sooner. Yeah, that sounded wrong. No, we on Monday there's going to be a Sierra stream, of course, but I am going to make charger instructions over the weekend. So, is there any sort of interest to, I don't know, watch me making instructions? Since I'm gonna make them anyway here on this desk, so I'm gonna, you know, disassemble the car, make pictures on everything, and I can as well stream the process if anybody is going to be interested in watching. If not, you know, I'm just gonna do it myself and whatever. The stream could be, I don't know, anytime during the day, and I'm probably not gonna, or am, I don't know how, depending on how I feel, gonna do it in one block. So, but making the pictures for the instructions will probably take me few hours. Let's say 3-4 hours, and probably this would happen in the afternoon. So if you're from Europe, it would probably be like from 1500 hours to, well, whenever we're done, basically. So if you're interested, I can stream it. I guess I'll stream it anyway, just so that you know. There will be probably a building instruction stream tomorrow. And then, of course, the regular programming starting on Monday with the continuation of this. So yeah, that's the general plan of what we're gonna do. So for tonight we are done. I am actually pretty tired. Again, as I say in every stream, please do support me on Patreon if you can. The link is here. You know, since Lego is expensive, every little bit helps. Since we have big plans and yeah, you know. Well, I'm gonna stream it all. When I stream, the camera is gonna roll, and you know, if you were watching, you're watching. I'm gonna read comments and respond to them in any case, and maybe explain what I'm doing if anybody's watching. So, you know, it's just if you want to watch it, do. If not, don't. I'll be streaming when I'm making the instructions. So, you know, at your leisure. So that's all for today. Support me on Patreon if you like and can. Thanks for watching, and I see you, well, I guess tomorrow.